Okay, so today we're going to talk about dividing fractions, and in order to talk about dividing fractions, we've got to talk about this term called a reciprocal. And it just means that you're going to flip a fraction upside down. So that's what I've put here is our definition for a reciprocal, and this is probably the simplest definition you're going to find, is just flipping a fraction upside down. So if I am going to do this, let's talk about a few examples here. So we want to find the reciprocal of each fraction here in my example 1. A, we have the fraction 5/9. So if I want to write the reciprocal of this, the reciprocal would just be this fraction flipped upside down. So I'm going to write it as 9/5. Okay, now I'm not saying 5/9 is the exact same thing as 9/5. I'm saying the reciprocal of 5/9 is 9/5. All you have to do is flip the fraction upside down. The reciprocal of 51/100 is going to be 100 over 51. And then the reciprocal of 5,000 over 91 is going to be 91 over 5,000. So all you have to do with this reciprocal is to just flip the fraction upside down. So we have some steps for dividing two fractions, and I've got them written down right here. The first step is to change the problem. Instead of division, we're going to change it to multiplying the first fraction by the reciprocal of the second fraction. So all that this means is if I have the fraction 3/4 and I want to divide it by 1/2, all I've got to do is say my step 1 is change the problem to multiplying by the reciprocal. So we're going to keep the first fraction the same, and we're going to multiply this 3/4 by the reciprocal of the second fraction. The reciprocal of 1/2 is 2 over 1. And then from there we can just multiply and clean it up. Now there are a couple ways to multiply, and we've talked about this too. You can cross cancel, or you can just multiply across the top and the bottom and then simplify. I am going to cross cancel since we need to be getting in the habit of cross canceling. Here, if I can think of any number that goes into both 3 and 1, the only number that I can think of is 1. And if I divide by 1, it's not going to help me out. But here, with 4 and 2, I can divide both of these by 2. We can simplify that by 2. And of course, I'm always looking at the ones that are across from each other. So I'm looking at 4 and 2, and I know that 2 goes into both of them. 2 goes into 4 2 times, and 2 goes into 2 1 time. So now my new fractions, I'm going to use these numbers to help me multiply. Instead of 2, I'm going to think of 3 times 1. So I'm going to have 3, and then I'm going to have this 2 times the 1 down here, and get 2. And if I want to simplify this out, I would say 3 divided by 2 would give you 1 and 1/2. So if you look at our steps for dividing, the first step here was to change our division problem to a multiplication problem. We changed it to multiplying the first fraction by the reciprocal of the second fraction. So we did that. And then after that, all you have to do is multiply that like normal. It is just a normal multiplication problem. So, and then when you're done, go ahead and change it to a mixed number if you can, and then you're done. You just circle your answer and move on. Our next page, we're going to talk a little bit more about some more of the division. Here, we're going to divide these different ones, and so we'll do each of these in turn. Let's do letter A. We got 9/10 divided by 2/5. In order to do this, my first step is to change this division problem into multiplying the first fraction by the reciprocal of the second. So I'll multiply it by 5/2. All I did was turn that second fraction upside down. Now, when I want to multiply here, I'm just going to treat it like a normal multiplication problem. I'm going to cross cancel if I can. Let's see here, with the 9 and the 2, I don't think there's nothing in there that I can divide by other than 1. they don't have any of common factors. So there's nothing that I can divide into other than 1, and 1's not going to help me to clean this up at all. So now I'm going to look at 10 and 5. So my 10 and my 5 here. And let's see, 5 goes into both 5 and 10. Hopefully we're all pretty confident with that. 5 goes into itself 1 time, and it goes into 10 2 times. So we have cross-canceled. Now our new numbers that we're going to multiply by are 9 times 5, which is going to give me, or 9 times 1, I'm sorry. 9 times our new number, which is 1 right here, give me 9. And then 2 times 2 here over 4. So if I want to clean this up a little bit, I do want to put this in the form of a mixed number. 4 goes into 9, goes into there 2 times. 2 times 4 gives me 8. There's 1 left over. So we actually have 2 whole, so 4 went into that 2 whole times with 1 out of 4 left over. And that would have been my answer. My next one over here, letter B, I have 9/11ths divided by 3/5. So in order to start this problem, my first step, I'm going to say my first fraction multiplied by the reciprocal of my second fraction. So I'm just saying multiplied by my second fraction flipped upside down. So 5/3. From here, I'm going to see if there's any way that I can cross cancel. With my 9 and my 3, 3 can go into both of them. 3 can go into 3 1 time, and it can go into 9 3 times. Then you look at the 11 and the 5. Well, the only number that can go into both 11 and 5 is 1. Remember, we've said that if you divide by 1, it doesn't change the answer. So it's not going to help us. So from here, we've got everything cross-canceled as far as possible. So I'm going to say 3 times 5 is going to give me 15. And 11 times 1 is going to give me 11. That is not going to change. I mean, anything times 1 stays the same. So now I have 15 over 11, which if I want to change that back to a mixed number, I've got to think of 11 going into 15. It goes into 15 1 time. 1 time 11 gives me 11, and I subtract and I have 4 left over. So this improper fraction can also be written as 1 whole, because 11 went into there 1 whole time, and 4 out of 11 are left over. So 1 and 4/11ths. Got a couple more here. We have 5 divided by 5/8. So here we have a problem because we have a whole number. Now, I can write this as a fraction, and it's not going to give me any trouble. It's just a little bit of an extra step. So let me go ahead and write this as a fraction. You can write anything, any number as a fraction by just sticking it over 1. I'm saying 5 over 1 divided by 5/8. Now from here, I'm just going to change it into a multiplication problem. So I'm going to have 5 over 1 is going to stay the same. I'm going to say I'm multiplying this first fraction by the reciprocal of the second fraction. So I'm going to say multiplying it by 8 over 5. So from there, I'm going to say, okay, can I cross cancel? Let's look at the 5 and the 5. Well, we know 5 goes into 5, and 5 goes into 5. 5 goes into 5 1 time. 5 goes into 5 1 time. So that's all nice and clean. And then we have a 1 and an 8. The only number that goes into both 1 and 8 is 1. So I am going to just, remember how we said that 1's not going to help us, so I'm not going to worry about it. So my new problem, I'm going to say 1 times 8 is going to give me 8 up on the numerator. 1 times 1 on the bottom is going to give me 1 in the denominator. And 8 over 1 is really just the same thing as 8. And then you're done. And our last problem here is a little bit messier because we have a mixed number to start off with. So here, again, I'm just going to rewrite my fractions. 7 over 11, I'm going to leave it alone. And I'm dividing this and I want to change this mixed number into an improper fraction before I can flip and multiply and all that fun stuff. So in order to do that, I've got to say 22 times 2 is going to give me 44. And then I've got to do 44 plus the 1. So 22 times 2 gives me 44 plus the 1 gives me 45 and all over 22. And from here, let's see here, I can multiply by the reciprocal. So here I'm going to say the first fraction, leave it alone. I'm going to multiply that first fraction by the reciprocal of the second fraction. Then I'm going to say, okay, well, look at my numbers, 7 and 45. Is there any number that can go into both of those? Again, and this one may be a little tougher because we know that there's like 7 times 6 is 42, and 7 times 7 is 49. So 45 is not really a factor of 7, so 7 can't go into 45. That keeps us from using that factor. But we know factors of 7. If this helps you, list out factors. Factors of 7 are just 1 and 7. Factors of 45, maybe a little bit, there's some more of them, and so you'll have to think through them. But if we're just looking for factors that they have in common, we're really just going to look at the factors of 7 really quick, since there's only 2 factors of 7, and see if any of these factors are shared between 7 and 45. So I just said a second ago that 7 was not a factor of 45. I mean, you can think through your multiples of 7. And so 7 times 6 is 42, 7 times 9 is 49. So we know that 7 cannot be a factor of 45. 1 is a factor of everything. However, it does not help us when we are cross-canceling like this. So that is not going to benefit us at all. We're not going to be able to cross-cancel between that 7 and that 45. Now look at 11 and 22. 11 and 22, we can cross-cancel. 11 goes into 11, and 11 goes into 22. 11 goes into itself one time, and it goes into 22 2 times. And I just want to finish this problem off. If I say 7 times 2, I will get 14. 1 times 45 just gives me 45. And guys, if we have cross-canceled everything that we possibly can, and if we simplify these fractions as much as possible, then there's no way we will be able to simplify at the end of the problem. So once we have done all of that, we know it's not going to simplify anymore. We've simplified as much as we could before we multiplied, and then that way we don't have to do it later. So just keep in mind the cross-canceling thing makes life a lot easier. I mean, in this problem, you would have had huge numbers if you'd multiplied 7 times 22 and 11 times 45. I would not have wanted to do that. And then you would have had to simplify. But so with the cross-canceling method, things were a lot simpler, made things a lot quicker, and didn't have to do quite as much mess. So just be aware of that. The dividing is honestly, all you have to do is set it up as a multiplication problem by multiplying the first fraction by the reciprocal of the second fraction. Remember that switch and flip phrase that you learned? You can think of that phrase in the back of your head. That is okay. But like I've said, if I ask for anybody to tell me the process for division, I need you to say multiply by the reciprocal of the second fraction, okay? Because that is a mathematical term for it. I hope this helped. Good luck on the homework.